And with that, I'd like to introduce Paul Mitchell, who has an equally complex title, which covers, I think, a multitude of sins. The head of Strategic Policy Technology Initiatives, which encompasses spectrum, but also internet governance and other things. Welcome.
Okay, thank you. So I had some slides, but I think I won't use them. Instead, we'll just have a conversation and maybe move a little more quickly to the part where you can ask questions of us up here. Talk a little bit about what Microsoft is doing in Spectrum and why we're doing it. And first of all, as Steve and Kai both basically made the point that there's a lot more abundance of Spectrum out there than we actually are realizing today. And I think the key point is moving a mindset from thinking about Spectrum as something that is a finite resource that is experiencing an insufficiency to one that is essentially an infinite resource if managed properly. Now, the management system we have today, I like the hotel metaphor, but it's basically state-of-the-art 100 years ago. And it hasn't really changed since then. And we have all kinds of technologies today that allow us to do much better management. Just as we have better traffic management on roads with traffic signals and things like that, we can have better management of our spectrum resource using databases and other sensing technologies that are coming online in the future. As one way to understand this and for Microsoft to get a better handle on what the world looks like in terms of spectrum, we've invested in putting some observatories up. Steve talked about open spectrum data, and this is something we are very interested in trying to extend. We have 3 spectrum observatories up today, sorry, 4, Brussels, Washington, D.C., and 2 in the Puget Sound area. We'll have 10 more up by the end of the next year. And these are available online. Anyone can access the Spectrum Observatory and all of the data that they are producing. They basically take a snapshot of all of the spectrum usage where they are located approximately every 3 seconds and dump it to a database, and you can sort on it by band, by time. And what you'll see is there is an awful lot of white space, not just in the TV bands, but in all of the other bands as well. Spectrum that is available, but for the most part not used. And the question for us is, how can we help bring that to a higher utilization? How can we use that to connect the rest of the world? Because as you can see, we have today about maybe 1/3 of the world that's really connected in a meaningful way to the broadband internet, and we have 2/3 of the world that is not. And for most of the 2/3 of the world that's not connected, it's not only non-available, but completely unaffordable. So we need to reduce the cost. We need to improve the availability. It's great that we've got more cables, more undersea fiber to Africa, but it's just the very start. And using Spectrum is one key way we can move it forward. Now, we've been running trials on Spectrum actually for over 10 years, starting on our campus in Redmond, Washington. We did some amazing things with sensing technology. We melted a bunch of radios. We had some accidents. But along the way, we figured out that we could actually reliably control use of spectrum with databases. And now we've been broadcasting in the Puget Sound area where Microsoft's corporate campus is for several years without any interference to any of the terrestrial broadcast stations whatsoever. We've extended that learning to trials in the United Kingdom, where we ran a trial in Cambridge for about 10 months, and in fact those radios are mostly still running. We also have a big trial going on in Singapore right now, and directly of interest to folks here in Africa, we have trials going on, and we don't think of them as trials. It's actually a real deployment of a network with Indigo Telecom in Kenya. And we will be doing something in Tanzania not too long from now as well. Now, each of these is our attempt to try to connect more people at less cost and in a more efficient way, because as the way we see the world, in the 19th century, we basically had railroads and steamships that connected the world and created the economy. Today, the only way you're really creating the economy is by being connected in the sort of global digital ecosystem. And the way to do that is with greater access to broadband. Now, the ITU Broadband Commission, the UN Broadband Commission, does an annual report every year that takes a look at what's the state of broadband, you know, how many people can connect, is it affordable, and what's the impact of broadband on trying to achieve the UN Millennium Development Goals. And last year's report concluded that there's been a tremendous amount of progress since the commission was first started, but at the same time, we still have this situation where about 4 billion of the world's population find it unaffordable. And to that end, the Commission has set in motion some additional work this year to try to really understand some of the hardest to connect areas, and taking a look in particular at the ways some spectrum could potentially be utilized. So with that, I think I'll stop now, and I would look forward to an interactive session here as we move forward.
Thanks, Paul. We've got about 10 minutes for questions or comments from the audience. Does anyone have any observations or any questions they'd like to forward? Please introduce yourself.
Thank you. My question is to Paul, Microsoft. Thank you for your nice presentation. You've talked of sampling a spectrum at 3 seconds and reporting it on web. That we've tried it in Washington, Cambridge, and also Singapore. Could you explain it like a bit more exactly how you're doing it, and how it could be used with the real radios to actually use, if you're using, for example, cognitive radios?
Okay, so the question is how did we run these trials? So we've been working with a number of radio vendors, Adaptrum, Newell, Six Harmonic. There's a collection of vendors, as well as chip providers, Broadcom, CSR, MediaTek, over the years, and that wasn't an exhaustive list, by the way, to try to move this ecosystem along. So our largest trial effort was in Cambridge. We combined with 16 other companies, including the BBC, BT, Virgin, Nokia, Samsung, a long list, to put radios, white spaces radios, in various locations in the city of Cambridge, and then test different types of scenarios. So today we don't have standards finished for white space chips in mobile phones. So today the white space devices are essentially a proprietary link between a white space's base station and a white space's end device. And the white space's end device can translate a white space's transmission into a local Wi-Fi transmission, or put it onto a wired network, for example. One of our demonstrations was to connect an Xbox, which is a gaming console, which has Wi-Fi capability, to a broadband network where the broadband link was the white spaces. So we had a white spaces base station, a white spaces access point, if you will, to which the Xbox connected, and then we could deliver interactive high-definition television, which is part of the Xbox video service. We could deliver that via that white spaces link. In Cambridge, we did several other user applications. We did location services. We had a trash bin that signaled when it was full and needed to be picked up and emptied. That was using some sensor technology from Newell. We did the basic broadband case, and both sort of a wide area as well as a smaller area. In Redmond, our corporate campus is there, and so on the corporate campus we have several radios between buildings that have basically been used as a pilot to test all kinds of different things. What modulation schemes are possible, when we were originally focused on sensing, trying to get the sensing technology to work well enough. It turned out that given where we are at this time, the sensing technology isn't quite there, and the US FCC was willing to go forward with database management, and so that's essentially what we are doing. In Singapore, the trial that's going on in Singapore right now, and there's an event in Singapore on the 17th of June if you're interested in attending. This is a commercial trial as opposed to a technical trial. So they're piloting different types of business models. One of them is Singapore's version of rural connectivity, which is the harbor. So they have 100,000 plus ships every year that need broadband access in the harbor for container loading plans and chart synchronization. They're doing that. They're also doing a smart city sensoring, smart metering thing with university campuses as well in Singapore. Does that answer?
In the back there?
Hi, my name is Mohammed Diop. I'm a telecom engineer, and I just want to come back on what have been done a couple of years ago when we tried to improve connectivity for Wi-Fi. I remember that there was a lot of things that have been done by the chipset processor like Intel. And when it comes to WiMAX and LTE as well, we know that they have been pretty much involved at the early stage of the WiMAX deployment when people try to get these things available at the chipset integrated with the laptop inside. This is one of the things that we did not get at the end of the day to have a better penetration of these high bandwidth devices available for connectivity. So my question is regarding this white space. Did we have any commitment with corporation like Intel to try to do something, or other chipset producer to make these things available at the chipset level and not just trying to get some external devices to allow people to get connected?
I think I can just go by the economic argument. It's a chipset vendor will start implementing if he sees a business case around it. This is part of the efforts we are doing to prove out there is a technology case, a sound one. Then it's a question, are there significant and sufficient frequencies available that you can make the case that people will actually use it, which was part of the reason, in my opinion, that WiMAX died, because you had a fragmented ecosystem and you had a very fragmented allocation of frequencies around the world for different purposes. And if you follow the money, it's very easy. The equipment vendor will sell to people who have money to buy, and if the people who have money to buy have no interest in the technology, then it will die. And that's I guess what happened to WiMAX. I think this is what I said before. It's a chance for the African continent to make the case that there is a requirement. It's 1 billion people, which I consider a significant market. So it's not, don't ask your chipset vendor what he can do for the equipment. Ask the people who buy the equipment to demand from the chipset vendor to be in there. I think that's the way I would phrase it.
Yeah, and I would just say that I completely agree with Kai here. It is all about a market potential. The other piece, though, that does play in is the standardization process. And the standards process for TV white space, at least for the Wi-Fi flavor of TV white space, is almost complete. So there's been a lot of engagement over the last several years developing 802.11.AF, which is the flavor of Wi-Fi that would run in TV white spaces. One of the reasons that you're not going to see a lot of proprietary chips built is exactly the case you saw with the fragmentation with WiMAX. On the other hand, you have the huge market of Wi-Fi devices, all different types, that if you can leverage that, is going to be very significant. Now, that does not address the machine-to-machine market, and there are efforts going on to standardize protocols for machine-to-machine as well to take advantage of it. But I think as you see those complete, and they're on path to, the Wi-Fi one is on path to basically complete and move into a certification program by the end of this calendar year. And at that point, it becomes safe for chip vendors to start taping out and making chips with some relative certainty that there will be something to build on.
We have time for one last question over here.
Yeah. Hello. Yeah. My name is Jonathan Pinful. I'm the Deputy Director of Spectrum Management from MACRA. And I would like to, my question goes to Paul. I would like to find out what's the maximum distance that you've achieved so far in terms of radio propagation from the base stations up to the end devices for the trial project?
So as you know, propagation is a function of the amount of power that you're willing to put against it and frequency. So we've not actually focused on direct length of propagation. We have done things that have gone in the several kilometers range, but given the deployment scenarios that we've been looking at in the urban markets, and which is not what we're talking about here, and the U.S. power limits, those limits would be smaller. So think about it as basically 3 to 9 times regular Wi-Fi in a radius, but that's completely dependent on how much power you want to put against it.
Okay, that wraps us up. Thanks, Kai. Thanks, Paul.